Rhombus, page 75. Definition: a rhombus is a quadrilateral having congruent sides, so all the sides are equal. Therefore, a rhombus is a special parallelogram, because as we know, in a parallelogram only the two opposite sides are equal, but here all the sides are equal. This is a rhombus. ABCD is considered as a rhombus, which is a special parallelogram. AB is equal BC is equal to CD is equal to DA. All the sides are equal. Properties: the opposite sides are parallel, the same as in a parallelogram. The diagonals intersect at their midpoint, at the same midpoint, and they are perpendicular as well. The support of one is the perpendicular bisector of the other. The supports of the diagonals are two axes of symmetry of the figure, and their common point is the center of the symmetry. The diagonals are the bisectors of the angles, as shown in this figure. These are the two diagonals, horizontal and vertical ones. They are bisectors of the angles. They cut all the angles into two equal parts. Conditions so that a quadrilateral would be a rhombus. How do we know that this quadrilateral is a rhombus? A quadrilateral is a rhombus if one of the following conditions is verified. First of all, it has four congruent sides, which is the definition. If we have a quadrilateral that has all the sides are equal, then it's a rhombus. Secondly, it's a parallelogram having two consecutive congruent sides. If two congruent sides are consecutive, then this is a rhombus. It's a parallelogram having perpendicular diagonals. If its diagonals are perpendicular to each other, then this is a rhombus. And also, it's a parallelogram having the diagonals, the bisectors of the angles. If the diagonals in this shape, in this quadrilateral, are cutting the angles into two equal parts, then they are bisectors of the angles. Then we can say that this shape or this quadrilateral is a rhombus. Application 4. ABC is an isosceles triangle of vertex A. M is the midpoint of BC. D is the symmetric of A with respect to M. Prove that the quadrilateral ABCD is a rhombus. We have ABC as an isosceles triangle of vertex A. M is the midpoint of BC. So it has AB is equal to AC because it's an isosceles triangle. We have M, the midpoint of the base BC, and we have D, the symmetric of A with respect to M. So M cuts BC into two equal parts because it's the midpoint of BC. So BM is equal to MC. And D is the symmetric of A with respect to M. That means D is far from M as A is far from M. So the distance between A and M is equal to the distance between D and M. So we have to prove that ABCD is a rhombus. We have ABCD is a parallelogram because its diagonals intersect at their midpoint M. M is the midpoint of BC as given, and M is the midpoint also of AD because of the symmetric. So M is the midpoint of both diagonals. We have M is the midpoint of BC. So AM is a median in the isosceles triangle ABC because it starts from A, which is the vertex, and goes through the midpoint of the opposite side, so it's a median. So AM is a perpendicular bisector, a height and a bisector at the same time, because it's a median in an isosceles triangle, and the rule says the median in an isosceles triangle is at the same time a height, a bisector, and a perpendicular bisector. Thus, AM is a perpendicular to BC. So AM is perpendicular to BC. That means we have 90 degrees at M. We have A, M, and D are aligned because of the symmetric, of course. So AD is perpendicular to BC. That means the diagonals are also perpendicular to each other. So as a result, ABCD is a rhombus because it's a parallelogram having perpendicular diagonals.